So I mentioned in part one the so-called Avraminko rectifier, which has come to be a shorthand name for single wire rectifiers, because like many of Tesla's patents, the single wire patent was so pioneering that it came out before diodes even existed. Fast forward to the 1990s, and the first modern diode rectifier for single wire transmission lines comes from this patent from 1993, and here's the US version granted in 2000 by two Russian gentlemen, Stanislav and Konstantin Avraminko, called Method and Apparatus for Single-Line Electrical Transmission. So let's just quickly skim through this one. I just wanted to look at the abstract and then figure 4. Provides a method and associated apparatus for supplying power to an electrical device, including generation and subsequent transmission thereof to a receiving device via a transmission line, the method being characterized by the transformation of the electrical energy which is generated into the energy of oscillation of a field of free electrical charges, such as the displacement current or longitudinal wave of an electrical field, the density of which charges varies in time, and the transmission of the energy via a transmission line which does not form a closed circuit, comprising a single wire transmission line, and, where necessary, its transformation into the electromagnetic energy of conduction currents. So they're distinguishing between oscillation currents and conduction currents. This is the crucial drawing. Check out figure 4. Figure 4 shows the power supply diagram for receiving devices operating on direct current. To supply power to electrical devices operating on direct current, the output of the single wire transmission line 4 is connected to an accommodation circuit in the form of a diode circuit, such that the output of the single wire transmission line 4 is connected to the common point of the anode of the first diode VD1 and the cathode of the second diode VD2, while the cathode of the first diode VD1 and the anode of the second diode VD2 are the outlets 01 and 02 to be connected to the receiving device 5, either directly or with a capacitor connected in parallel. Or alternately, a transformer circuit, figure 4, employing two interconnected inductors L5 and L6, such that the receiving device 5 is connected to the inductor L5 via the rectifying circuit. So that's just saying that there's a sender and a receiver, like we're doing here. Notice that the top version is actually running straight off the high voltage single wire line. There's no step down transformer. And then notice on the bottom version, there is a step down receiver coil, but it's not grounding the high voltage part of the receiver. It's connected to a conductive body. That last part is the one part I have not been able to reproduce very well. I still ground my receiver coil because I can do it connected to just a metal mass, but it gets maybe 20% as much power input. So that's the Avraminko patent, and shortly following that, we've got the Strebkov and Avraminko single wire electric power system for renewable-based electric grid. Abstract. He describes it as a reactive capacitive current for transmission of active electrical power. We've got a Tesla transformer applied to the generator site to generate high-frequency reactive capacitive current, and a reversal Tesla transformer and standard rectifier and inverter at the user's end to convert the reactive high-frequency electric power to standard 50 or 60 hertz electricity. A single wire electric power system has quasi-superconductivity property for reactive capacitive current flow along the line even at high operation temperature of the electric conductor. It has no resistance losses for the following tested conductor materials: copper, aluminum, steel, tungsten, carbon, water, and damp soil. I have so far tested it with copper, aluminum, and carbon and water. I like the way Strebkov describes it. Discussion. The step-up Tesla transformer generates during a half cycle the charges of high density and high electrostatic potential. The free charges are moving along the line from generator site with high potential to the user's end with small potential, and this capacitive charging current is stipulated by Coulomb forces. These charges are moving on the surface of the wire, and the current is not affected by Ohm's law and Joule law. So, Tesla transformer is operating during one half cycle as an electrostatic generator, continuously generating free charges and supporting high potential at the generator site. In the following half cycle, there is a change of the sign of charges, which are recharging the line capacitance. A displacement current in the space surrounding the wire corresponds to change of an electric field strength. The displacement current, as well as capacitive charging current, is not affected by Ohm's and Joule law. 100 years ago, Nikola Tesla developed his apparatus for transmission of electrical energy using single-wire technology. He considered that one terminal of the secondary and primary coil of the step-up and step-down transformers must be connected to the earth. That means that the single-wire line can be applied only to the power transmission along the earth. Now we know that electric power can be transmitted to anybody not connected to the earth. For example, to an air balloon, plane, or even to satellite. We don't even need to apply a step-down transformer for single-wire power transmission. We can use for power transmission non-metallic conducting media like isolated water tubes, cables made from carbon, or conducting oxide on glass. We developed single-wire electric power system using laser beam as a single-wire line. What? New principles of electric power transmission using capacitive and displacement current. In the future, these can be applied for the construction of united global solar electric power system for the world. In conclusion, the single-wire electric power system uses a one-pole, single-wire, open-tuned circuit, capacitive and displacement current for transmission of active power. Modified step-up Tesla transformer was applied to the generator site to generate high-frequency reactive capacitive current, and a reversal step-down Tesla transformer or diode capacitor block was used at the user's end to convert high-frequency reactive power to a standard 50 Hz or DC electricity. So we've got the cinder coil on the left in figure B, the receiver coil number 7 on the right, and then a rectifier here and the load. So that's more or less the setup I've been testing. And then that led me to this expanded version, some textbook, chapter 19 by Dmitry Strebkov and others, single wire resonant electric power systems for renewable based electric grid. And I just want to skim over some of this stuff, just check out what kind of things they're suggesting here. At the beginning of the 19th century, there were no diodes and transistors for pumping resonant circuit and a transformer. Nikola Tesla used the method of impact incitation with a spark arrestor with 96% transmission efficiency. At the end of the 20th century, we used a thyristor frequency converter with 25 kilowatt capacity, water cooling with 86% efficiency and 400 kilogram weight. Currently, frequency converters on silicon transistors with 97% efficiency and 30 kilogram weight are applied. That sounds like progress to me. Uh, and even more lately, 20 kilowatt inverters on silicon carbide transistors with 98% efficiency. Covers the same patent drawing as I've been interested in. Goes through a comparison of classic electric engineering based on the use of alternating current in a closed circuit versus Nikola Tesla's electric engineering based on the use of reactive current in an open circuit line. Anyway, trends of future development of electric engineering and the energy industry. So Nikola Tesla has left behind the following technologies for further development. 1. Single-wire resonant technologies for power supply to stationary consumers. 2. Technologies for wireless power supply to surface and sea transport. 3. Technologies of directional electric power transmission through conducting channels in atmosphere and space. In the 21st century, these technologies make it possible to develop 1. Fuel-free rockets with electric rocket motors. 2. Extremely long-range electric power transmission lines with lower losses than in superconducting cable lines. 3. A unified energy system. 4. A global solar energy system with terawatt transcontinental power exchange and 24-hour electric power generation for a million years in the amount of, wow, terawatt hours? Strebkov in this piece is talking about using single-wire transmission lines to interlink all the different continents of Earth, collecting solar power 24 hours a day wherever the light is, and transmitting it all around the Earth. The global solar power system. In order to set up the global energy system developing Nikola Tesla's ideas, we propose electric energy transmission through high voltage, single conductor, cable, gas insulated lines, and the use of 3 solar energy plants in the deserts of Australia, Africa, and Latin America as energy sources. Thus, Russia proposed the model of the future world development based on direct conversion of solar energy at solar power plants and transcontinental terawatt power streams with the use of resonant waveguide technologies suggested by Nikola Tesla. Single conductor cable lines covered by Nikola Tesla's patents will replace overhead electric power transmission lines, which will considerably increase reliability of electric power supply, reduce rates of injuries caused by electricity, and free considerable areas of fields, cities, and forests. Humanity will be able to unify energy systems of all the countries into a global solar energy system of the Earth to provide decent living conditions for everyone and to implement large-scale scientific and technological projects, both on the Earth and in space. Heavy stuff. So I'm going to just conclude with that. Couldn't have said it better myself.